Now that we've defined a simple random sample, how do we select one? So many times the first thing that you'll do is obtain what's called a sampling frame. And a sampling frame is just a list of every possible individual that's in the population. Now you do have to be careful because sometimes your sampling frame that you choose does not actually include everybody in the population. So take, for example, a phone book. Now, maybe 30 years ago, the phone book did contain almost everybody in the population, but today, a lot of people are not listed in a phone book. So if you were to use your phone book in order to select your sample, you would miss everybody in that population who wasn't listed in the phone book. So this would not be a particularly good sampling frame. But if we wanted to get a sample of students, then we could get a list of all the students at the college. That would be a great sampling frame because it would include every single student. One of the most essential things about collecting a sample is that it is truly randomly selected. Human beings are not very great about actually producing random sets of numbers. So we don't want to rely on ourselves. We want to do something that is completely random. We can do that by giving a number to every individual on our sampling frame and then pick random numbers. There's a few ways to do that. You could write each number on a slip of paper and put it all in a container. Or you could use what's called a table of random digits that is usually available with a statistics textbook. Or now that the technology is available, we can actually use an online random number generator, and many graphing calculators have a random number generator programmed into the calculator. So there's a lot of different ways that we could randomly select our sample, and we'll be looking closer at creating a random sample using StatCrunch in one of our labs. There is a definition here that we do want to pay attention to: sampling with replacement versus sampling without replacement. In an ideal situation, we should always be sampling with replacement in order to have our probabilities stay consistent. But we wouldn't want to include somebody in our sample twice. So we don't really have to sample with replacement as long as our sample size is pretty small compared to the population. The probabilities won't be too different. So even though we should always be sampling with replacement, we'll use sampling without replacement for practical purposes. I want to make a quick note about the sample size because you might be thinking, well, how can it be possible for me to take a small sample of, say, 100, 1,000, maybe 10,000 from my population of several million? And how can that sample actually tell me something useful about the entire population? So it'll probably take all semester for me to truly convince you that this is an okay procedure, but I can start by showing you a simulation that was performed. So here we have the entire population of SAT scores for seniors in California. So this includes every senior who took the SAT. And you will note that just for consistency of And you will note, just so that this graph was a little bit easier to see, each dot is going to represent 3 observations. But now I want you to take a look at what happens when we take samples. So the bottom one has a sample of 50. Then the next line is when we have our samples of 100. Then the middle line, samples are 250. Then second from the top, samples are 500, and then from the very top, samples are 1,000. You'll notice here that when we plot the results from the samples, that they're still centered around the same population value. So let me go back to the population graph. Here, it's centered around 500, and in all of these graphs, it's still centered around 500. So we see that our samples were very similar to what we saw in the population. Now, when our samples Now, when our samples were small at the bottom, we don't see quite the same shape of the distribution, but as our sample size got up to 1,000, we started to even see the same type of shape occurring in our samples. So keep in mind that it really is fine for us to take samples that are much smaller than the population and be able to obtain results that are reflective of the true population.